Hello guys, welcome back. In this video, we will talk about like data types. This is I think the sixth video of our series to learn a way to learn Rust. So in this video, we will discuss the data types. So there are multiple data types in the Rust. So let's look at what's it trying to say. So the first line itself says that when we create a variable using the let and the guess, then we use this method to like string. We have 42 input from the user, then we need to parse, right, and expect if there's something went wrong, we expect a error. But here when we try to just use it without this u32, it will show an error. If there is no u32, it will show an error while parsing. It will show error that I don't know what to parse in. So at the time the type must be known, right? So that's the thing we need to add, and here is the suggestion, right? So what are the data types available in the Rust? We will see in this video. So we are talking about like scalar data types. So in the scalar data types, we have integers, floating point numbers, boolean, and characters. These are like primary data types available inside the Rust language. So let's look at the integer data types. So in the signed integer data types, we can write I instead of like u. U is a stands for unsigned, right? So here are the different length of the data, which is like 8-bit data. We write a sign. For the signed, we write I8, and for the unsigned version, we write U8, right? So and for the 16-bit, we write I16 and U16. For the 32, same, and 64 120-bit and arc is I size and U size. Architecture is like you have to write I, then the size, and we have to write U, then you have to write the size. Then each variant can be either be signed or unsigned, has an explicit size. Signed and unsigned refers to the whether it is possible for a number to be negative. In other words, when the number needs to be have the sign with it, it's signed, and whether it is only ever the positive number can therefore can be represented without a sign, unsigned, right? So if we write like 2 to the power minus 7, sorry, 2 to the power 7, and in the front we have minus or the negative 2 to the power 7. So that thing we can represent using and signed value. And if you don't want to like write negative or like a negative version of the number, then we can directly use like unsigned version. So no need to just represent the sign on the front of the number, right? So we can use this one, unsigned one, and if you need the sign, then we can use I1. Okay, and then we have also those additionally I size and U size. The type depends on the architecture of the computer of your program is running on, which is denoted in the table as arc. Okay, 64-bit if you're running on 60-bit architecture, and 32-bit if you're running on 30 architectures. Okay, that is the format actually that we need to uh, just think of, like as the CPU is a certain kind of support 64-bit or 32-bit, then it depends on I size and U size, depends on the CPU capability to process the data. Okay, next we have like decimals. Okay, these are the decimals: hexal, octal, binary, and byte. Okay, integer literals in the Rust. We have numbers, decimal point. Example, if the decimal is like 98.22, and then we have hex. We need to have 0x, then ff. Total value is 60. We have octal, the binary. This is how we write binary. Then we have byte. We write how this byte. Okay, this is good. So this is how we write like the data inside, right? You can read also here, like you can write integer literals in the form as shown in table 3.2. So this is how we write the decimal values or hexal or octal or binary or byte values, right? Okay, then so how we do know the views? If we are unsure, Rust defaultly generally good places to start. Integer types are default size I32, primary solution I size or U size when indexing some sort of collections. Okay, so integer overflow, when the integer overflows, right? This was situation like we have the variable of type u8 that can hold a value between 0 to 255. If we try to change the variable to value outside of that range, such as 256, the integer overflow will occur, and which can result in one of the two of the behaviors. Either if you're compiling in the debug mode, it will check integer overflow and cause the program to like panic. Okay, and if it's in the like okay, here it is given, if in like a release mode, using the release flag, it will not just check for the integer overflow and cause panics. Instead, not cause panic. Instead, overflow occur as perform two components wrapping. In short, value greater than the maximum value type would wrap around to maximum values that types can hold. In this case, you add value to 56 become 0, and the value to 57 become 1. Okay, and so on. It will then again convert the value. Okay, that's good. Then to explicitly handle the possibility of overflow, we can use this familiar methods to provide by the standard library primitive numeric types, which is like your wrapping underscore star methods, such as wrapping at return none value if there is overflow, which is like check method checked with the checked underscore star method. Return the value to the boolean indicating whether there was an overflow. With overflowing, the underscore star methods saturate the value maximum with value saturating underscore star methods. Okay, we can use this method if there is an overflow or the situation of panic. So, or actually, what is panic is like when we have the certain value of the limit, and the result we are expecting is greater than the limit we have already assigned to the variable, then it will just cause panic. Simply is that you can see here the rest includes checks for the integer of overflow that cause a program to panic. At the time, if the variable of rust uses the term panicking, okay, when a program exits with an error, the same thing, right? Okay, now then we go to second data type, which is floating point types. Second scalar data type, which is floating point type. So floating point type is like 2.0 when we use decimal, and then 3.0. So it could be like F32 and F64, or F floating point 64 bit or floating bit, right? It's capable of more precision. Okay, let's read this. Rust also has two primitive data types, two floating point numbers, which numbers with a decimal points. Okay, Rust floating point types of F32 and F64, which are 32.64 bit in size, respectively. The default data types is F64 because on modern CPUs, it roughly the same speed as F32 but is capable of more precision. Okay, so that's how we define the floating type. Let x is equal to 2.0, F30, F64, and let's y is equal to F32, 3.0, F32. Okay, for the F32, we can just need a double colon and use F32 as our data type, define the data type for the like floating point types. Then we have numeric operations. We perform the numeric operations. Like let sum is give the variable name, then give a plus or a minus, then we can multiply or just divide. Okay, we use let to create a new variable out of it. Okay, now we have the third scalar data type as like boolean data type, which will contain either true or other false, and can be like defined using we have double colon and then bool to write the type of like boolean type. Show the type of like it's of boolean type. This is how we show. Next we have a character scalar data type. Have in a character, it will just write written as double colon character, then we'll give equal sign, then we write the character or the single character value inside the single quote, not the double quote. So it's of like most primitive alphabetic type. Here is some examples of. Okay, not that we can character letters with the single quotes as opposed to the string literals, which used double quotes. Rust character type has a 4 byte in size, so the each of the character only 4 bytes is assigned. Okay, represents a Unicode character scalar value, which means it can represent a lot more than just ASCII. So letters with accent like Chinese, Japanese, Korean characters or emojis, 0 bit is called character values in Rust. Unicode is Unicode scalar values ranges from U0000 to U plus D7FF, and that is to this one. Okay, inclusive. Okay, character is literally a concept in code, so you can use character to replace a single value or could be accented value letters. not available as a string letters or like escalators maybe. So we have the also the compound types. The So first one was like scalar type and second was like compound type. Compound type is made using grouping of the like scalar types. So the first in the compound type is the tuple type. A tuple is generally a way to grouping together numbers of values with a variety of types into one compound type. Tuple have fixed length. Once they declare, they cannot be grow or shrink in size. So we create a tuple by writing comma separated list in a value inside the parentheses. So this is how we write like tuples. Okay. So we have let, then name of the variable, then we define with I32, F64, and you. Then we assign the values. Okay, and then let XYZ how we use inside the that variable inside the like functions. If we define just write XYZ, it will just take the tuple. If the tuple is like 50, 500, 6.4 and 1, then we need to print the value of y. Y should be like 6.4 because we have like okay. So we can either access the tuple by directly by using period. How we use which is y which is 6.4 or the same thing I have explained is written here. Okay, now we have the period followed by the index of the value we want to access. For example, okay, we have now the this tuple defined, and then we have 500 is equal to x dot 0 x 0. Okay, now we have this of the thing, then it will just add each of the x dot 0 means zeroth element to 500, right? We can directly just take the value I want the zeroth value, then I will just type the name of the tuple, then dot, and directly access the means the number which is the zeroth index, and just take this. Okay, now we have the array type. Array is defined using like the square brackets inside each of the variable written by commas, the group of commas, and we can just try to use like this. Okay, and variable could be like integers or any scalar type, right? Any scalar type we can just write under the square bracket, then that this is like of array type. And we have I32, and we can define the size using like after we can define the type and size using the double colon, then defining the type under the square bracket, and then giving semicolon and defining the length of that array. And we have this. Okay, then this array will contain 5 elements. This is how another way to defining the same thing about same to same. It's got three means this each element will be three, and we have the length, total length will be like 5. We have 1 2 4 5. Now accessing the array's element, this is how we access the elements inside the array in the Rust. So we have total array defined like this, and we have the first, we will just take the array, the array name of the array, then give the index inside the square bracket, and this is how we take the elements from this array. So we will see all this inside the Rust. Now we have the file name. This is the how we finding the sample main.rs for letting the array, and then we have index, then string.new, then we are taking the input, then taking the index and writing whatever the index we want as output, right? Let's go to the example for all of this at once. So we are not going to define each thing in separate. Let's go into our VS Code, and we have everything defined. We're already just showing some of the information. Let's check it back. A tab. So we have four of the scalar data types. This is how we comment in Rust. We have scalar data types. Okay, the first one is what was the first one is like integer. So integer are of like various types: I32, I64, I128, and I8 or I16. Or unsigned is like U8, U16, and like this. So how we define first the name of the using the let it know we are creating variable, and then name of the variable, then we define it, give it the type, right? Give the type after semicolon, we will type I38 or 32, sorry, I32, and give it the value of like 5. Okay, then we will get let and give it y, and it's going to be unsigned like u32, u32, and this value will like be 6. Then we have floating point data types, and we have floating data types. The how we are going to define floating point data types using f, right? We just write let and then define ft floating point, give it a type like f32 or 32-bit. There are only two types, right? F32 and f64. F32 is defining for 32-bit, f64 is defining for 64-bit. For default, by default it will take 64-bit. This is how we define 32-bit. So define 3.0. Okay, not 2.0, let be 3, and that's of 64. Let ft is equals to 6.0. Okay, see, it's taking, already taking its type. Okay, I like define it f64. Okay, we have now floating data types. Now we have character data types. Character. Okay, this is the um, fourth item actually. The boolean data type I will define after this. So how we define the character? We will just define let and define the name of the variable. Let's suppose x. Not x is already defined. We will define h and give it a type of like car, and define, give it the equal, and just define it under the single quote. The single quote, define anything we want like a single character. That's it. Now we have a boolean data type, right? Boolean data types, and how we are defined, we will define let, and the define is not defined. Give it a type of like bool, and then give it a value of like true or false. It depends on you. Let's be true or let's be false, like this, right? And to print this, we can need to just print ln statement, and it will should auto all should work, right? I just saved it. See, haven't used any of this variable, so it's showing error that we haven't used it. Then just go below it, if this is information of like B. Because see, you can unused variable b, here it's giving us the information regarding this, right? Then we just use println, and we'll define each of this, right? Like x, then give us y, then give us like, so we have defined the same thing with the 264. Take the value of 6, not the 3, right? We will just change it, and if we just fy ft, then give us fy, give us another variable h, and then we have like b. You can predict the output. I will just it like cargo run very quick to let it print. It's building now, and you can see 56368 row, which is in sequence. So we have 3.0, 6.0. Just converting it to like integer. We can visualize it. We'll save it and let it cargo run again. Cargo run. Okay, now you can getting 3.1 and 6.4, right? So if it's 0, it's just ignoring that. But the type is already defined f32, it will act as a float only. Okay. Now we have a compound data types. In the compound data types, we have run, I think, two things. Which is first one was like tuple, and second was like array, right? First one was tuple. This is how we defined, and the second was like array of string or anything we want. That's a simple thing. I think we can need to just see the examples and directly copy it, because I don't think this will make any sense just creating and copying it. So just copy. We are going to design the same thing, doesn't matter. Just enter it or we delete it in time. Just clear it. I have already seen the examples for like the scalar types. Just paste it. This is the first type of the like compound data types. and we have I3264 defined, and we are going to take the value of check the value for y is the second variable, which is 6.4, so it should output like 6.4, and give it a save, and give it a like cargo run. And if this is intentional, okay, we haven't used x, we haven't used that, okay, that's go. Okay, this is completely fine because we don't want to use all of the output, but we are getting this value is 6.4. We are getting the second value. What if we write z, control s, and just clear it first, clear, and then cargo run, and we are getting like value 1. We are getting value 1, which is absolutely correct. And these are the just errors warning that we haven't used x, unused variable y. Okay, this is not an like actual error in the program, but if you're defining something, we should be using that variable that the program mean to say. Then not this one, where here is the just arrays. So instead of just defining the array, we should be using this one, that a is equal to 3 5, and let's see if this prints the array of length 5 with the value 3. Let's go to VS Code, just close it, paste, okay, and just little, and here we go. So we have defined a variable a, which is of type like I32 5, and which is give it the value 3, and of the 5 times, like let's print it, print ln, and value of arrays, and arrays, that's we, I think that's we say, and control s, and then cargo run, and it should give the output, right? Okay, we got something. Cannot be formatted the default formatter, so we cannot format the directly. I think, let's see what is going on, how we just can print it. So let a we have this one. This is how we get the second value. So without the formatter we cannot just print it, and we haven't learned the formatter yet, so we can uh, use it here now. So in the future video, maybe we will just about formatter more. So at this point, if I want to access the elements of by using I let let b variable b is equals to the array is a. I want to access the value of like second element, and second value would be also be 3. In this case, the value b should print us 3, right? Let's do this, clear, and just cargo run, and building, and we are getting a value of 3. What if we change it here, change it to y5? What should be the output? The output should be 5 only, because all the values of the array is same, so the output should be 5. Anything like 7, all the values of the array should be 7. So what if we cargo run it? Output should be 7. Okay, that's good. So that's the simple thing. I think formatting we will learn in the future videos. That could be our advanced concepts, but still now we haven't learned the formatting yet. So that's how we handle type of data types in the Rust. And thank you so much for watching this. Hope you like and subscribe.